Alright, so Newton's first law states that an object will remain at rest, or an object at rest will remain at rest until it is acted upon by a non-zero net force. So basically what that means is an object like the stack of pennies or this paper will stay still, will stay not moving until some other force acts upon them and causes them to move. Okay, and so when I take my finger and I apply force, the objects start moving. Now there's also Newton's first law also is in effect for motion as well. An object in motion will stay in motion unless acted upon some other force. And so if I stop moving it with my finger, it stops moving, which tells us there must be some other force acting upon the paper after I let go of it. We've studied earlier in the trimester friction, and that's the force that we know is stopping the paper and the stack of pennies after I stop applying force to it. That friction is an opposing force to motion, and so it stops motion. But these objects remaining at rest, they'll stay there until I once again apply force to them and cause them to move. Now, part of Newton's first law says that I'm only acting on this paper, right? And so the motion of movement should only be for this paper, yet we see these pennies moving. And so there has to be something else at work here that's causing these pennies to move when I apply force to them as well. But watch what happens if I apply force in a much more rapid manner. So if I lick my finger and make it wet to increase the friction between my finger and the paper, and then go really fast, watch what happens. So you can see the pennies did not move at all. And I'll show you that again here in just a second. So we've got my setup, right? My pennies on the paper. I'm applying force to the paper, and that's causing my pennies to move. But then, if I apply force really quickly to the paper, then those pennies don't move, right? They might move a tiny bit. I think those ones might have moved a little tiny bit that time. But for the most part, they don't move, and the paper moves extremely fast. Okay, so that right there is what I want you to do today, is to look into that. I want you to plan an investigation to experiment a little bit with your own stack of coins and paper. I want you to ask yourself some question related to what's going on here. I showed you the pennies moving when I apply a small amount of force with the paper, and I showed you the pennies not moving when I apply a large amount of force with the paper. I want you to ask some starting question involving that, and then do an investigation. So remember, that investigation involves having the starting question, and then coming up with a hypothesis, and then creating an experiment to test your hypothesis. And while you're doing it, make observations and record your data in a data table, and then come up with a conclusion. Now, on this one, I'm being a lot more open-ended than we have in the past. Normally, I'd give you a very guided lab paper to tell you exactly what steps to do and how to do them. But on this one, I want you guys to have some practice coming up with the stuff on your own. So, like I said, come up with a starting question related to this, come up with a hypothesis, and then decide how you're going to experiment on it. There's no one right way of doing this. I can get a lot of different results back in the end, which is fine, but I need you to make sure that, that you have all those elements. The starting question, the hypothesis, the experiment with observations and a data table with all of your results, and a conclusion.